Yeah, we have done that. Get finished.
Yeah, so obviously like instead of, so within the same method you can actually do that.
Implementing in get
But,
finished.
So
In this case, he's actually replacing the
when you find
the
the
figure.
largest knowledge,
Everything will be replaced.
you have to delete that file. So you still have to call this function,
Which function?
the same function. So you have to delete, meaning that you have to delete it from the 6 left check.
You already have a reference to the delete, right? You already have a reference to the delete. Just delete it. Delete equal to null.
You're deleting two nodes essentially. That's
You
what
are
it is.
trying to delete this one, right? But what you're doing is you're saying 5 dot left will be 6 now, right? Right. But 6 already contains 5, so you have to delete it. You have to delete this node.
You're only deleting one node.
Yes. So 3 you delete it, right?
We don't delete.
No, we copy the
We
data.
replace the background here and then we delete this one.
That's what I'm saying. So for deleting this one, you have to still have to call the delete.
Why do you want to delete it? You already have a reference over here, right? You always get a reference to this one just like that.
So you are saying it will be like this.
Then
It will be like this.
okay. Can we go on?
Yeah, sure.
You can. Remember, optimizations and the best solutions are not essentially required. At least have one solution proposed.
Yeah.
So, okay. You have, yes, this is a computer. If you have a tree on one computer and you have to pass it to another computer, how will you do it?
You want to pass it tree?
Yes, and then you have to rebuild it over here, same to same. Copy? Okay.
Like problem is like when I need to copy.
Yeah, you have to transmit.
Yes.
Yes. Now, unfortunately, I can't lift it and just put it here.
So definitely there could be some kind of serialization like we want
Yes.
to convert
So
into-
how would you serialize? So the question is, you have to serialize a tree here
and then
Deserialize.
and then deserialize it here.
Right.
Okay. How will you deserialize and how will you
Maybe
serialize?
create two traversals, preordain and
Uh-huh.
send it over the wire and reconstruct using those.
Okay.
I don't know the algorithm.
Go for it.
This is just
Pre-order is pretty straightforward, right?
Sorry,
Which one will you use? In order, pre-order, post-order?
whichever is easiest.
Oh, everything is the same, right? Everything is the same.
I don't know.
It depends where you are putting the root, it will become straightforward. So, if you were to have, I don't need a binary search tree.
So it's just like conversion from
So you are converting
Pre-order and
from,
pre-order to a tree.
okay, how, which one will you call as a pre-order, which one will you call as post, I mean, which one will you use? First of all, we need to decide that. And let's say we don't have which traversal will we use? In order?
No.
Okay.
Traversal will give you this tree,
This-
but you can't construct the same tree using the same traversal.
Why not?
So you need to
why
We
pre-order?
need two traversals to
we
create a
start
To pre and post.
One at a time. You are saying
we'll start printing from the root node.
pre-order, okay.
So 1, 2,
Why pre-order?
because we need root first when we transmit the data. Right?
Okay, that's a good point. So you have root, okay. Then in this case it will be 1, 2.
And this is a binary search tree, right?
No.
No, no,
It has to be.
order is required.
in order as well. Why? Why can't you do it in one?
Why can't we use like breath first and then put a comma after each level or the script? 1 and then we have comma 2, 3, comma 4, 5, 6.
Then you put in one delimiter,
But how will you get to know that 6 is on left child or right child?
delimiter.
What if you have already
Yeah.
you can have
What if
two
you have
delimiters.
instead of, you can still do it.
You can still do it.
You can still do it. So every node you have to put in something for its children.
Oh,
So let's say if you were to have something like this,
put null.
Yeah.
and over here you put a hash. Yeah, you can do BFS, but
We have to
I'll do,
reconstruct it back here on the
Yes.
other side.
you can
Yeah,
do it.
so if you are putting a hash, then it's usable.
Yeah.
If you put in a delimiter now. Same way over here now, you can't put in a null as such, because you're not passing pointers. Pointers don't make sense outside the boundaries of the memory. Okay, so for pre-order, we'll use 1, 2, 4, 8, 9. Actually, we'll have 2 hash, 9, 2 hash, then 5, 1 hash, 11, 2 hash. So essentially, you are just putting in delimiters. So I'll write the serialize and deserialize. That should make it simpler to understand.
So DFS is the best solution or what?
BFS is a good solution, but I already said how you can look at BFS. I'm just gonna do another one, pre-order also. You can always print it out as and when you encounter. For my purposes, I have just put them in a queue. I'm using pre-order, yes.
With that has
Yes. You can define any delimiter that you like, then use that delimiter.
so any other solution?
BFS. Why?
in that also we need
You always need a delimiter. Otherwise, you will not be able to reconstruct a tree, or you will have to have multiple traversals to compare your values.
I remember like using 4 traversals you will
You can always do with two traversals.
So just after this if you know the logic using 2
Okay,
traversals.
we can walk through it. I don't know the logic at the top of my head, but I'll try to. Is pointed to for group and passing the key. And This will ensure that you are enqueuing all the nulls.
Where are we adding delimiters?
None.
Why do we go this?
So when you come to 8, over here it will go as 8 left, that is a null. It will encounter null, it will enter null, but it will say this is, I cannot access any more further, so it will go back, come here, it will say again 8's right is also a null, it will put in a null, and then it will not go through this, it will return back. Yeah, these two are in this condition. I'll write DC extension. You're returning null. What I'm doing here is I am getting the value out of the queue. I'll put it in temp data and then temp left, because the pointers that I have passed here are of no sense in this particular computer. So I am reconstructing it. The other way to do it is just enqueue this with integers. The problem with integers that I face is I don't know of any good delimiters in integers. You can always pass in as string.
one more, right? You can just use the array, put the binary tree with the same delimiter null and just use
The same, like whether you use Q or array, right? We still have to.
No, but delimiter, I mean, while constructing the binary tree, you use the index left will be 2n plus 1, the index right will be 2n plus 2 till you encounter the just key.
Yes, but then you'll have to know what size your array is going to be. And
That-
second thing is you are actually going over a network. You will not be able to pass an array over the network. You'll be passing data one by one.
Yeah, I mean,
You'll be
instead
receiving
of
data
Q-
one by one.
Instead of Q, I'm saying array. Anyways,
That's
like
it.
for Q,
How will it be? Like, are you trying to improve it in some way? So I think if you do that, you will be doing an in-order traversal in an array.
it
No,
doesn't matter.
actually you're doing a pre-order only in that case. I'll come to you in that is a good point. The next question I'll ask you. Depends on that.
So, like, as storage, you can use array of any different. How they going to serialize? For serialization, what algorithm are going to be used? That's important. Are you three or
Same traversal.
Same towards it, okay. We're putting in the array set for queue. And on the DC part, how will you serialize?
2n plus 1 will be left side, 2n plus 2 will be right side. The heap sort
But in order for such,
we'll discuss.
Click here.
somebody doesn't get it.
I'll give you beautiful question where the hint that I need to use tree was the last hint that I got. Fifth hint. You're getting it the first one. Let's say you have a class that has ID.
Then you don't have to do your branch first. Then it will
Class.
Yeah, the order is only required. Left and right.
Some.
Only the order is only the order.
Okay. You have multiple nodes. They are not linked, so it's not a linked list. The IDs are in sequence from 1 to n. Okay. Let's say. Okay. Equal to n. This is the code in every node. Class node. Okay. It has its own identifier. There are 1 to n nodes, all in sequence. Each node has some data in it. It doesn't matter what. Some data.
What is the in function?
This there is a receive. So the receive function actually passes in a parameter ID. So if node 1 wants to receive some data from 2, it will be listening on receive 2.
Okay.
And 2 will have to pass send 1 and whatever the data is. Okay?
So what
So
are
the-
we doing here? Like,
So the question is, all the n nodes should have the sum of their data in this value. So let's say, I'll give you one small example. You have 1, you have 2, and you have 3. This has 5, this has 14, and this has 23. Okay? So this is 37 plus 5, 42. So your total sum is 42. After whatever code that we are planning to write, it is run. Everybody will have 42. How can you solve this problem using trees?
So 1, 2, 3 ID, 5, 40, 23
Is
the
data.
and
then yeah, you have to update this value. Initially this is 0 or whatever, doesn't matter. At the end, all the nodes should have the same value, sum.
so at any point in tree, if I update any of the value, automatically it will trigger an update all.
No. You have to write the code.
Yeah, to update all the.
Yes. How will you do it?
So, how each node knows like where the other node is? How it references?
Doesn't matter.
Doesn't reference it?
When it does receive, the receive function takes care of that, and the send functions take care of it. You don't have to worry about it.
So we need to at least do the two traversal, one for getting the value and second for updating the value.
Yes. Okay. It's
My
fine.
question is like how this node knows like there are.
It knows all n. It knows all the
But
nodes.
we are passing the ID, right? We need to know the ID.
Yeah. Because so ID is from 1 to n. So if you know n, you know your own ID, and you know it is starting from 1. Every class knows that.
Okay.
And you don't have to write the receive and the send function.
Okay.
This is already given to you. You have to implement. So this one will have void update sum.
So is it a tree or what? Which format it is?
It's not a tree. It can be anything. These nodes don't have to be anywhere.
Oh, these are not interlinked with.
They are not interlinked with each other. They are communicating through receive and send.
Okay.
This is a very interesting question.
Yeah. It's interesting.
So the very first solution I proposed was n square. Send to everybody.
Yeah, brute force.
So send. So what I proposed was, let's say you are here. You will send your data to everybody before you, and they will calculate the sum, and then they'll give you the sum, and then send that new sum to everybody after you, and then they'll give you the new sum.
But in that case, only my data will be updated, not rest of the data.
But then you can start updating everybody's data, right?
So there
And then the second,
From first node,
Mhm.
send the data to
yeah, send the data to the second one. The second one will
Will
send
be
the data to the
updated.
third one. The
second,
third one will
second
send.
one calculate the sum and update its own value,
And-
and it will send
Yeah,
the updated
so
value to the
it
next
will-
one.
This one will send whatever the sum is at this point in time
Uh-huh.
to the next one.
And it will add to its own self.
It will do the self, and then so finally this guy will get
The
the updated sum, and he will start. He will send it to everybody.
Yeah.
Yeah, send
That
it.
takes 2n, not
Yeah.
n square.
Yeah, that's true.
Okay, that's true, and improve the solution. I propose a second solution. Make this one a server. Everybody has to give it the sum. Actually, yeah. And then this one will send it to everybody. Again, it is O of 2n, because the first one I proposed was O of n square.
Yeah.
So this one was an improvement. It's like, okay, improve it further.
Do we have to construct a tree or something?
Think. You have the biggest hint, trees. I didn't have that. You had to spill it out. So what if you got to use a tree?
Is this like, is there a way we can get the max or those
The max?
max of n or?
No, you know the n. Everybody knows the n. Everybody knows what the max is.
So receive from everybody and then send.
No, you can receive only from one person at a time.
1% time. We can loop.
One node at a time, sir.
We can loop through, right? Like we pass on ID, different IDs
Yes.
from 1 to n.
Yes.
Receive all the
Yes.
values and then just send one.
But you'll have to send one to everybody.
Yeah. Which is no n, right?
Yes. I proposed O of n. He said improve that. Improve that.
But without communication, how would you receive the value? There's supposed to be one communication.
What is the optimization? I mean, O of like login we have to do or
I want to tell you that you know the solution.
No. I mean,
O of login, yes.
O of login.
Warm login can only be achieved by tree.
But how?
Binary.
No, one thing is, even if you say O of login, it's not possible. If you start constructing a tree, you still have to traverse the n nodes.
Yeah, but
So constructing a tree.
the other thing is you can't create threads. First solution that I said, like create threads.
No, but even for constructing a
You
tree,
can.
you have to take O of n, right?
You can. You will traverse through all the nodes, but that doesn't mean you have to take off n time.
How? I mean,
Think if I were to give you that and you'll solve the problem. I'll give you that.
and are they sorted like? I mean, are they ascending order like 1 to n is?
Everything from 1, there is everything from 1 to n.
It has everything.
Yes. Like there are nodes from 1 to n, and all nodes know what the n is. Does that make sense? So if there are 50 nodes, all 50 nodes know that there are 50 of us in total.
And they just don't know the data of them.
No.
Okay. If I start constructing a binary search tree with respect to data, and if I
With
add,
data. Okay.
yeah, and if I add data, the rightmost node will always be the max.
Okay, but then first let's stop there. You have to construct the binary search tree based on data, correct?
Yeah.
It's already on. Just constructing already achieve on.
No, that's what I said, right?
So your binary search tree based on data will be O of
n.
how will it be of n?
So you just like.
This data is not in ascending order or descending order.
No, if you start,
No, based on the IDs, you keep on passing IDs, you keep on receiving the.
Comparison
data.
itself will take like which one is the
Construction you'll have to find out which
Yeah.
is the middle one, because you need to know the largest one. So you'll have to first sort it and then you can
it's
construct
a
the
binary
binary.
search tree, right? So, like, let's say if I start with the node 1, right?
Okay.
Node 1 will be a root. Now next I encounter, let's say, a value 2. So 2 will go on to the right hand side.
Okay. First one was
1,
1. Okay, sir.
right?
2.
2.
reconstructing also will be done, right? In middle if you find like a
At that point in
100 or
time-
something.
Or
You need to
worst
look at-
case scenario, you will just create a linked list,
Yeah.
either ascending or descending.
It's a binary search tree, right?
I mean, I have
Exactly,
balanced
balance.
it.
You'll have to
Yeah.
keep balancing it.
Yeah.
Balancing
balancing
it whenever I
because-
add.
yeah.
Balancing is.
That's the can. That's what I said, right? If I
Okay.
have to construct, then I can always find the rightmost
Okay.
with the.
Okay,
Okay.
you did that. After that.
So if I have the binary search tree with the data, because every time I add, I make a sum and
Mm-hmm.
set it to the rightmost side.
You still. So you okay? Let's say you got the binary search tree, irrespective of what the cost was. Now,
So while constructing only, I have to keep adding the sum.
you have to keep adding the sum.
Yeah, so if I encounter the 3 nodes,
Mm-hmm.
right? So the right node, the sum is already there. So
So we can create a binary tree with respect to the IDs.
Good point. Okay. What
And
ordering will you use?
in order,
In order.
yeah.
So, what will this be?
n by 2.
N by 2,
Okay. This will be.
N by 4, 3, 3 and 4.
Okay. Instead, if you were to do pre-order, correct? Now this is responsible for passing the data to only to its children. How does it know its children?
2 and
2 and
plus
plus
1
1
and 2 and plus
Correct? And it is responsible for receiving data from only 2. So it will send its integer data to 2 guys.
2 guys, and they
And then after some time it will receive the sum of their trees. So that again. Yeah. I couldn't come up with that idea. He had to give me hint after hint after hint. It's like, oh.
So this 2n plus 1 is the
Left child.
left child,
2n plus 2 is the right child.
and 2n plus 2.
And the leaf will know because it knows n. It will say 2n plus 1 is greater than n, then I don't have children.
But again, we have to update that.
So you will receive the data from at the most 2 people and you will send the data to only one person. Your parent, one parent. And you will receive from at the most 2.
But again, I have to update rest of the nodes also, correct?
So the way it will start is, okay, I'll write the code, yeah. You have to do 2 iterations
Yeah.
of send and receive.
Yeah.
Yes. So, void update sum will be, so I have my sum, I will pass it on to my children. So first we say for leaf, if 2 into id plus 1 is greater than total, then I don't, then I just receive, then I will send first. Send to 2 into id plus 1, whatever my sum is. So I am sending the sum down. Yes, first time I will receive. So before this. If not ID greater than 1, we will say we will receive from my parents. So receive sum plus equal to ID by 2 what will be over here, ID by 2, what will be the parent. So 1, 2 and 3.
It's 2.
ID by 2, that's it.
ID by 2 is all the parent.
What is the parent? So you just receive, then you will send, and then you will go through it again to update the sum, but in the reverse order. So you are receiving your parents' sum, then you are sending it to your children, then your children will send you the new sum.
Then again, parent will send.
But this, you just keep going through it. That's all. Easiest is go bottom up. So if you are the leaf, only then you will start sending the sum up. And then when you go to the root, you will have the sum. At that point in time, it will start sending the data.
Add it and
Getting this trick is the important part. So the flow will work like this. If you are at leaf, I didn't write the code. If you are at leaf, you will send the data up. And if you are not at leaf, you just expect your children to send you the data. Once your children send you the data, you will receive it, and then you will send that data to the top. This one will actually get the sum,
Two operations.
and then it will send it down.
So if you start with 8, you will send it to 4 and 12.
No, you will not start with 8. You will start with 2, 6, 10 and 14.
Why?
Because your sum will get generated over here and then into operations. If you were to send it from top, they will not know the entire sum.
Okay.
It will have to go down and then come back up. Over here, when you go top up,
So you have to call like all the leaves has to be.
so yeah, so that's why if you are a leaf, send your data to your parent.
But where is the equation of the loop?
Oh, yes, you want the code? Be like this. There is no recursion.
There is no equation
There will be no recursion. You just
for the loop.
it will be leaf. So if 2n plus 1 2 into id
So actually half all the nodes which are
is greater than n,
Greater than
only
half are
then
leaf, right?
you will send to parent. So id by 2 comma whatever your sum is. Correct? If you are not a leaf, you will wait for your children to send you the data. So you will say
actually
yes.
the leaf will be all the nodes which are half of the that side, right?
Yeah.
So those will have that trigger.
Yes. Else you will receive sum plus equal to receive from rho into id plus 1 comma rho into id plus 1 and receive from rho into id plus 4. Correct? You have received it. Now you are sending it to your parent. Then you will send it to your parent. Send to id by 2 sum. Correct? Once your 8 will actually get this sum and it will say if, and it will start sending it up. So it will then start sending send to 2 into id plus 1 and 2 into id plus 2. That's it.
You think ID is going to be, so this code is in the loop, ID will be from 0 to n, 1 to n?
No. This code is in the node. It is on running on every node.
You have to trigger it only on the leaf, right?
So your sum will start from the leaf.
From the
From there it will start going up.
Need to be triggered from the leaf, right? Who's triggering it?
The code has to handle that. So that's why it started. If I'm a leaf, I'll just send the data up. Otherwise, I'll wait for the data to come and then I'll send it to my parent. Yeah. So then, at this point in time, 8 will come into picture. You will see if id equal to 1. Just start sending the data. That's it. Otherwise, actually no, you don't have to care about that.
Because I do.
Yeah. id equal to 1 will have to wait, that's all. Just receive. This will take care of it for id.
Is this question somewhere in the book or?
It was asked to me last week.
How did it go?
What do you think?
How do you notify the lead?
You will, this is sending it, right? You will have to receive as well. I have not finished the code. If you want, I can write the code. I have not written the code.
Yes, like
videos, I think that you guys might have received a lot of emails late or night. So that thing actually breaks the videos into like different parts. I'm currently adding all of them together. So I'll send another link. So disregard that one. I'll send another link which will have just 2 videos. So we'll have just 2 videos for that, and we'll have 2 videos for this class. And
Is it open or what?
I have closed it, everything. So only the people who are in this, I added their email addresses. So only those people can view it. And like, once you guys tell me if you want me to delete it, I'll just delete it. It's not a problem. So yes, and tomorrow we'll do testing, and I'll go through all the questions which are there in that book, the Career Club book and the other book, and whatever is left, I'll cover that plus testing. And then like Wednesday, let's not do Wednesday. Let's do on another like Saturday, Sunday. Like you guys tell me when you are free.
That will be
So
long.
not in Saturday.
Huh?
That will be long weekend, I think so.
No,
that class,
that is not long weekend.
That's not long
weekend.
Yeah, and after that.
So we'll do that, the object oriented, and I will try to steal that guy's hours and try to figure out, like there's a guy in my office, he has very good libraries and stuff like that. So the object oriented, I want to have a class in which I can do it like him. So the classes that she has written in her book and the other guys have written, it's just like simple class. There's no interface, there's no templates, there's no like those kind of things. So I want to do it like that. So next weekend we'll do that. So, and if you can write some things, like this is totally anonymous, nobody knows, like I'll just go outside and enjoy the weather.
Why did you bring the baseball bat?
So enjoy the weather, it's really nice, and